I have a series using integral test. Is this series convergent or divergent? Okay, first of all, I will put the series in a function. So I have x over x squared plus 1 quantity square. And then we need to check that for x greater than or equal to 1, this function is continuous, right? Is continuous. How do you know? When x is greater than 1, do you see any vertical asymptote? I don't. The bottom is square. There is no 0. There is no undefined when x is greater than 1. Okay. And then also is positive. Okay, let's see. The numerator is positive. For x greater than or equal to 1, the denominator has a square that is positive. Okay, to save a little bit of space, I will move this up a bit. And then for the derivative, so this one for the derivative, you have to use the quotient rule. After you use the quotient rule, you have this x squared plus 1 to the third power. It is supposed to be a square. That must have some simplification right there. And then the top, you have negative 3x squared minus 1. Last time I wrote a 3. I don't have the work for my integral test. Okay, here. This third power. I am not sure if this is from the algebra, so maybe this is a fourth power. I don't know, because the square of a square is a fourth power. I don't have my work for the quotient rule. So you can take the quotient rule, just be aware of this. But however, even though that is a 3 or a fourth power, for x greater than or equal to 1, the denominator is guaranteed positive. So a third power, a fourth power, that doesn't change anything. What matters the most is this minus. You have a negative divided by a positive, so that proves the function is decreasing. So f is decreasing. And then you can do a check, continuous, positive, and then decreasing. So now you can use the integral test. Okay, using the integral test, you have integral from 1 to infinity. I have x divided by x squared plus 1 squared dx, that is equals to, present the improper integral, let b approaches to infinity of the same thing. Okay, duplicate. There we go. And then is this an integration by parts? No, this is a u substitution. I am going to let u equals to x squared plus 1, and then du is equals to 2x dx. And then put that to the left hand side, 1 over 2x du, that is equals to dx. And then we do a change of variable, so we change of this variable, and then you can see that the x will be cancelled. Okay, go back to the writing. I have let's don't mention the limit, let's just do an integral. I have x divided by u squared, and then the du is equals to this. Duplicate. Since that is in du, there is no more x in the integrand. And then I have 1/2, and then u to the negative 2 du, integrate. The 1/2 stays there. This is u to the negative 1, and then there is a negative 1 in front. So we have a negative 1 divided by 2 over u is x squared plus 1. That's it. That is after the integration. So at this point, the integration is finished. I will move on, and then let's move that up as well. I have a limit as b approaches to infinity. I have negative 1 divided by 2 x squared plus 1, and then this goes from 1 to b. And then plug in infinity. I have 2, and then this will be infinity, minus negative 1, plug in a 1, and then I have 2, 1 squared plus 1, and then this will be a 0, negative 1 divided by a huge quantity, and then plus 1 over 2 times 2, that is a 4. So that is equals to, oh no, equals to 4. That is equals to 1 over 4. And then what does that mean? We have this summation, a series. So I will just copy and then paste that series. And then this series is equals to this integral. this series is equals to integral, and then the integral is equals to 1 over 4. So I'm going to draw an equal, and then equal. So that means the sum is equals to 1 over 4, and then this is a finite sum, and then therefore we can say the series converges by the integral test. So the series converges by the integral test. Okay, some tips for you to do this kind of problem. Most people will just integral test, right? Most people will just focus on the integral. Okay, we do a u substitution, integration by parts, we do this and that, and then we come up with either 0, infinity, or a real number, and then okay, say okay, real number 0. Okay, then the series converges. I highly recommend you to go back to the very first line, see where you started. We started at a series, and then we let that equals to integral, and then the integral is equals to 1 over 4. So I want you to spend one line. Okay, that will just take you like less than a minute. Just write a conclusion. You start from here, you went through here, and then you reach to a 1 over 4. And then the sum is finite, so that you can see that the series is equals to an integral equals to 1 over 4. The sum is finite, then we say the series converges by the integral test because the area under the curve is equals to 1 over 4. Alright, so that is the end of this video. If you like the way I teach integral test, you like the way I explain this type of math, give this video a like, subscribe to my channel for more contents like that, and I will meet you all in the next lesson. Signing out.